Helio College math students. We're looking at a very interesting relationship here. It's the effect of scale on area. We're not going to be talking volume, just the effect of scale on area. And also, really here, we're looking at perimeter. So perimeter and area. Oops, learn how to spell perimeter properly. Perimeter and area. So I'd like you to work through this example here on page 16 on your own first. So if you haven't done that, pause the video and have a go at it. Although I will just clue you in that the way these dimensions work with the scale factor. Here we've got a 2 by 3 rectangle. So if we scale that up by 2, scale factor of 2, then those dimensions double. So it becomes 6 by 4. And by 3, scale factor of 3, we've got a 9 by 6 rectangle. Okay, so go ahead, pause the video and work out the perimeter and area of each of these shapes. Okay, so here we've got 2 plus 2 plus 3 plus 3 gives us a perimeter of 10 centimetres. Here our perimeter, when we add them all up, we should get 20. And for the last one, 30 centimetres. Now the areas, 2 by 3 is 6 square centimetres, 4 by 6 is 24, and 6 by 9, 54. Okay, so the question is, what can you say about the effect that a scale factor increase has on the perimeter and area of a figure? So let's do some dividing here to work out these scale factors. The original is really, I suppose, just a scale factor of 1, because if you multiply by 1, it stays the same. So the original scale factor is 1. When we go up by 2, what happens? All right, let's see the perimeter, 20 divided by the original, 2. Oh, that looks familiar. There it is there, 2. So the increase in perimeter, the factor that the perimeter is increased by is the same as the scale factor. Does that work for the last one? Let's see. 30 over the original 10, so we're always dividing by the original. That's 3, so it does match. So it seems that if we increase a shape, the perimeter will increase by the same factor as the scale factor. Does that work for the area? Let's find out. So we're starting here, we've got 6. Okay, so we'll go this new area over 6 is 4. It's increased by a factor of 4. What about this one? 54 over 6. It's increased by a factor of 9. Those numbers don't match. Now you might be starting to get an inkling about what the relationship is. Maybe you want to pause the video and just think about it for a while before I say anything. Okay, now if you're not sure what the relationship might be, let's see. Let's write down the scale factor. Scale factor. I'm just going to make a little table up here. The first one, we've got a scale factor of 1, then 2, then 3. So with the perimeter, we can see that matches. The factor is the same for those. But with the area, we're getting 1, 4, 9. So how do these numbers relate to the scale factor? Have a think about it. Maybe pause the video and think for a while. Now the answer is that to get this factor for the increase in the area, we need to square the scale factor used. So 2 squared is 4, 3 squared is 9. So to find out the factor for the increase in area, we square the scale factor. Let's say that we increase by a scale factor of 4. Well, the perimeter for these rectangles, we won't worry about these circles, but for the rectangles, the perimeter would increase by the scale factor just 4, but area would increase by 4 squared. It would be 16 times larger. Now, this might seem like a pretty, unimportant relationship, but it actually is quite important. It comes up in real life phenomena. For instance, a really important one is stopping distances in cars. We see this same increase, scale factor increase. Let me show you this visual here. Okay, so stopping distances for cars. Now, if a car with the same mass, these cars have the same mass. Oops, go back. Where is he? There he is. Now, if it's going at 10 metres per second, it'll stop in 1 metre. But if you double the speed, you don't double the stopping distance, it actually increases by a factor of 4. So doubling the speed, 2, the scale factor is 2, 2 squared is 4. If you quadruple the speed, so 4 times as much, 4 squared, 16. So this is really important to remember when you're driving a car, is that doubling your speed will lead to a much larger stopping distance. It doesn't increase in what we call a linear fashion or at a steady rate. So keep that in mind for road safety. Okay, look in the description for the video for the questions to try for the effect of scale on area.